Okay, this is your review on outcome N5 in the grade 9 curriculum on estimating or calculating perfect squares of rational numbers in both fraction and decimal form. The first question says, which of the following numbers are perfect square? And it says 1/25th. So remember, back in grade 8, you learned the perfect squares. You learned the first one, 1, 4, 9, 16, etc. And you learned that those were perfect squares because when you looked at their factors, each of these numbers has an identical pair of factors, or a number that when multiplied by itself gives you said number. So perfect square, perfect square, perfect square, perfect square. If 1/25th, which is a fraction, not a whole number, but a fraction, is a perfect square, then there must exist in the world a fraction that multiplies by itself to give you 1/25th. And in this particular case, there is, because using that idea, the numerator is a perfect square of 1. The denominator is a perfect square of 5. So therefore, this is a perfect square. And if I wanted to elaborate further, the square root of 1/25th, I could then say is 1/5, because 1/5 times 1/5 equals 1/25th. In your second question, based on the exact same method, is there a fraction that when multiplied by itself is 121/400ths? This makes it slightly more The difficulty with this one, as opposed to the one before it, is that a lot of us don't know our times tables beyond 10 times 10. But 121 is a perfect square because 11 times 11 is 121. And 400 is a perfect square because it's 20 times 20. So then therefore, I could say, yes, this is a perfect square. And if I want to elaborate further, the square root of 121/400ths is equal to 11/20ths. Now with your next question, C, is 1/10 a perfect square? So is there a fraction that multiplies by itself to give you 1/10? Well, the numerator works because it's 1 again, but there is no denominator that when multiplied by itself gives you 10. So therefore, 1/10 is not a perfect square. And if I was to check this, of course we know that 1/10 as a decimal is 0.1. So the square root of 1/10 or the square root of 1/10 in a calculator, if I put the square root of 1/10 in a calculator, it should give me an irrational, non-terminating, non-repeating decimal to just verify that, yeah, 1/10 is not a perfect square. The next question is not a perfect square as well, for the exact same reason I said. So the numerator is a perfect square, but the denominator is not. So therefore I say no, it's not. Double check with the calculator. What's the square root of 9/10? It's an irrational, non-terminating, non-repeating decimal. So there is no number that multiplies by itself to give you 9/10. For E, we think that it might be because, of course, 25 is a perfect square. But if I read this, I get tenths, hundredths, thousandths. It says 25 thousandths. And what fraction times itself is 25 thousandths? Again, numerator works. We're feeling pretty confident that it might be. But then we get to the denominator. And some people think 100 times 100 is 1,000. No, 10 times 100 is 1,000. So there is no denominator that will work. And therefore, it is not a perfect square. Verify with a calculator. Decimal 0.25 square root. Non-terminating, non-repeating decimal. So there is no number that multiplies by itself to get you 25 thousandths. And the last question, is this mixed fraction a perfect square? You cannot examine mixed fractions and determine whether or not they are perfect squares. You must change them to improper. This will be 25 ninths. And of course, what fraction times itself is 25 ninths? It's 5 thirds. So therefore, we can say, yes, this is a perfect square. And to elaborate, the square root of 2 7/9 is equal to 5 thirds or 1 2 thirds. Your next question is actually a grade 8 question. A grade 9 variation might be something like this. You might be asked, what's the square root of 30.4? But using a number line, this is kind of just still a good question to ask for this chapter because it's still relatable. I would make this the square root of 25, which is a perfect square of 5. The square root of 36, which is 6. So right now I can say that the square root of 30 is 5 decimal something. And if I was to approximate it, it's just a little bit before middle. somewhere around there. So I'm going to guess it's like 5.45, or I'm going to say 5.5. Why not? Roughly, just before middle. And if I take my calculator to see the square root of 30, it's 5.477, right? Which makes sense where I put my dot because it's just before the midpoint. Square root of 80 fits between the two perfect squares of the square root of 64, which is 8. The square root of 81, which is 9. This one's pretty easy because it's just before this one. So if I was approximating it, I'd say 8.9, maybe. Verify with a calculator. Square root of 80 is 8.94. Question 3. Square root of what number is 0.2? On the test, when you were given this particular question, what I ask you to do is you think about an easier question. Or sorry, the square root of what number? And give yourself something you know the answer to. So the square root of what number is 8? I know the answer is 64. So I ask myself, with the information I was given, what can I do with that to get the square root, the unknown square root? The answer is you square it. So if you square the known quantity, you will get the square root value. So with that in mind, if I square 0.2, I will get my x. So x will equal 0.2 squared. X will equal 2/9 multiplied by itself or squared. X will equal 1 1/4 squared. And x will equal 1.1 squared. So if I take my calculator for the first one, what is 0.2 squared? And use your square button or multiply by itself. The square root of 0.04 is equal to 0.2. The second one, I probably wouldn't write it this way with fractions. I would probably say is equal to 2/9 times 2/9. And the reason why I would do that is because I could see it easier. Therefore, the square root of 4/81 is equal to 2/9. Same thing with the next one. I wouldn't write it as 1 1/4 squared. I would probably write it as 5/4 times 5/4. And therefore, the square root of 25/16, or the square root of 1 9/16 is equal to 1 1/4. And finally, 1.1 squared. Just take my calculator. 1.1. Well, I know 11 times 11 is 121. So I'm pretty sure it's going to be a variation of that. And it is. It's 1. So x is equal to 1.21. And your final question says a rectangle, which actually was a mistake because I shouldn't have said that, a square. But of course, a rectangle is a square, so we'll see it in a second. I'm going to draw my rectangle, and I'm going to say this is 2/5 of a meter. I'm going to say this is the square root of 0.16 meters. And of course, the first thing I know is I cannot calculate area or perimeter if it's in these types of forms. I can, but it's much easier to convert them to decimals. 2/5 is equal to 4/10, which is equal to 0.4. So instead of having a fraction side length, Riley, I could have a decimal side length. Same thing. The square root of what number, or the square root of 0.16? Square root of that is 0.4. So really this is 0.4 meters too. And when I convert that over, I realize, oh yeah, it's a square because they're both the same side length. So the area of a square, the formula is side squared, and the perimeter of a square is 4 multiplied by the side length because there's 4 equal sides. So what is 0.4 squared? Area would equal that. It would equal 0.4 times 0.4, which is 0.16. So the area equals 0.16 meters squared. And finally, there's 4 side lengths, each of which is 0.4. So the perimeter is 1.6 meters.